All right, so we're doing this again, doing something a little different and hopefully better audio quality because the 3D printer is off. So today I'd like to introduce a standard for uploading 3D printed designs or just designs that you have in general without the 3D printer involved. But I wanted some sort of format that was well, I can basically read what I've written, but I'm tired of seeing all of these like 6 different websites that you have to like log into with OAuth and people being like, oh, there's incentives for you to post your thing. Like, no, we really do have already um, platform agnostic open source infrastructure to facilitate the development of engineering projects over the internet, namely Git, right? So the this is my STC template. It's a repository as a source. It serves as a source of origin of the original design and drawings and kind of critical dimensions for your projects. It's a template, and it also acts as a compendium holding all of the knowledge that you'll need in order to replicate whatever design you have made for other people to use over and over again. Uh, and I want to bring 3D printing into mainstream viability and streamline the process for downloading and utilizing 3D prints. It's just way too hard the way that we do it with Thingiverse. I think you'll see at the end of this that my method is perhaps more scalable. It might take a little more effort from the designer, but there are plenty of people willing to put in the effort as long as, at least I will assert, that a lot of people will put in the effort as long as people will actually use their designs and they know that they're going to get not even like rewarded, but just like people will be grateful that they put that effort in. And I think if you do put the effort in with a good format rather than putting all this effort into like a Thingiverse or whatever, you'll do a lot better. So let me show you kind of the file structure. It's super simple. It's not supposed to be complex. There's a bill of materials, if you have it, critical dimensions, which is a raster or vector image. It's like an image that you actually have of the 3D printed part or design that you're trying to make. Then here's where I think this is going to provide a lot of value to people. If you put G code for a bunch of standard printers that you do own, or like, let's say the Bamboo Lab stuff is very popular, as well as the sort of like Ender 3 clone type bed slingers, right? If a lot of people contribute to this repository and make pull requests with the G code that is working for them to print this, people can just clone the repository and get going, just drop the G code basically into Octoprint or whatever they have going and go there beyond even future thinking as well. If you have everything set up in this STC format, you can sort of scrape the web for all of these files together and very easily make a like web page with a bunch of different designs that are described already by the README file, and they already have G code for people to just like, you hit the button on some web page that's connected to the internet, connect to a repository of designs that are sort of mirror something in this format, and suddenly it's printing over in your garage, right? Like, this is what's going to bring 3D printing from something that like a bunch of nerds do in their mom's house, like me, to something that like an established, everybody does this, because instead of getting something in 2 days from Amazon, you can get what you need in a matter of 2 hours. Like, every single person can have it. It can be like a washing machine or a dryer or something like this. So what I think, you want your parametric source, your STL, and the G code, and even the critical dimensions. Because what if your parametric source is from some platform that is like archaic or just not very popular, but it's like very high end perhaps and was really good, and you want other people to utilize it? Well, you're gonna need to have the some way that you've put all the most important information that people can, on their own terms, like redesign it and then make it either a derived STC or make a pull request to add their parametric file to this STC. And to sort of demonstrate how this works really quick, I wanted to show, I made this bearing, print in place bearing. It fits into a Schedule 40 2-inch PVC fitting, right? So I want to replicate. I want to like let people use this, and it's not going to be too difficult to, it doesn't really need a YouTube video. I think there's a million YouTube videos out there of people making these print and place bearings. People just need somewhere that they can go and find like, oh, a bearing with a 58 millimeter outside diameter or whatever they're looking for at the time, right? Um, and then download something and get it. So let me show you that file. Okay, so here it is. And you can see already the value that you're providing here because from any sort of Git repo, you can just pull the critical dimensions down. And if the designer has done a good job of dimensioning their part, you'll be able to just basically, so this was designed in FreeCAD, but a lot of people are using Fusion 360. So you can just take the basic shape of this and change it. All I have to do is look at it and I instantly have the design. I don't need to see a YouTube video. I don't need to spend 5 minutes watching a YouTube video at 2 times speed in order to get this information. It also has additional information. I think I'll probably add, it'd be a good idea to add a chamfer at the bottom. It also says the radial play, so how much the center part can move left or right. And how it should be printed, and basically like why I even designed it fits into here. But you could put like, oh, this is to fit like a standard size shaft, or to fit into something, or it's just like something from a handbook where you have a table of different sizes. Like if somebody were to go and spend the effort to make a whole bunch, like a 5 millimeter bearing, 10 millimeter bearing, 20 millimeter bearing, you could just throw all that information here, and we'd be able to scrape it later in the future when we're trying to make some sort of program as a collective. We're trying to make a program that lets normies basically use this stuff. You can very easily pull that sort of data and place it in your website so that it's tabulated, and normies can go and search for what they want very quickly. So just again, the next step is I want to kind of show where did I pull this up? 1 second. Maybe here. Yeah, this is it. So how a designer would go. Oh, so this is what it basically, I just showed you already what this is. This is the same, right? And it's very easy for me to upload this to Git through the standard protocols, right? If I make a change to it, like let's say it has like an OD and what other information do I want to add to this? Oh, to bottom of raceways from okay, so like I added some additional information that I actually do want on the repository. Very easy. Git add all. Getting very excited. Commit added additional compendium, or just additional dimensioning information. All right. Hopefully I don't dox myself. Yeah, freaking love Linux. All right, so now what I just put, refresh this, so easy, right? So easy. And now you can have contributors doing the same thing. And frankly, I don't know why we haven't done this before. It also is resistant to any sort of like business cycle stuff with Thingiverse or Ultimaker or like Prusa. Like these sorts of things go out of business, but open source software is timeless like that, you know? Really good, well-designed open source software like Git is just timeless. What if you want to make a new project, right? So I have this drill guide. I placed it somewhere right here. So I derived this off of somebody else's design. It has a bunch of holes to help you drill. But what I noticed is with the a like number 9, 2.5 inch construction screw, if I use the 45-degree angle drill guide, which is on this face, um, the tip of the screw goes through. Standard 1.5 inch actual dimension, but like a 2x4 or like a 2x10 or whatever you have. If you have the short dimension like this and you're butting it against another board like this, and then you put a screw in at the 45-degree angle, you're going to pop out the other side with your 2.5 inch thing. So I decided to make another drill guide with a 31.4 degree thing for everyone to use. Now, let's say I want to distribute this. Well, first I need to make some drawing files so that people actually use it, right? So 1, 2, so okay, I got the top, all those are dimensioned right, and this. And it doesn't have to be perfect. It's basically up to the designer to do this. But if somebody else wants to contribute, right, like it would be nice if every designer did something, right? But one of the easiest things for people in a community, like let's say you have a YouTube channel and you want to release a design, you don't really have to do this, but you can ask like, hey, I will give you a shout out in my next video if you go ahead and dimension this for me, or like make this repository nice, or make some build instructions, right? And you like community source the process. And I think a lot of people would be enthusiastic. Like basically, I would be enthusiastic about this because I think there's a lot of people who have made incredible things that I really like to use, and I have no way of really contributing my time directly to them in that project and be part of it. So you come up with your dimensions. You go here to the package repository for the template, which I'll just do here, and copy this. And then as a designer, I go to the folder where I hold all my STCs, and I git clone. Excellent. Now I just take this, rename it. So STC underscore 90 45 31 -4 drill guide. And I have all of these. So we don't really need the bomb. There's a fake file in here because you need Git doesn't really preserve the file structure unless you have a fake file. Parametric source. I'm going to throw in my Mark II remake. Well, actually, I guess I was going to demonstrate. It doesn't matter. It's going to demonstrate iteration, but I think this video is just going to be too long based off of the rants I've already done. So here's my parametric source. Let's throw our drawings in here as well. And delete the fake file. README. Erase all of it. Okay, and not really pocket screws, but you know, I think people get the picture of what I'm trying to say. Put the board together and you want to go at an angle. Okay, so we have we need the STL file still, so let's drop that in there. And then I didn't actually go ahead and prepare the G code, but what I was expecting would be good is that if people put G code in for PLA and PETG for a printer that they have, just whatever printer they have, and then the community updates this later. So here, I've gone ahead and done this in PETG and PLA, and they should both work with the tolerances I have here. But it'd be good to add any notes you have to the file name. So anyhow, again, you do the same thing where you basically have to set an origin if you're making a new repository, unless you like clone you make a template. Like you can also do this sort of thing. This might actually be the preferred method. Is first go to your thing, fork it, and then make it a template. And then if you were to make a new project, you can go STC real guide. Template? Source template con. So I made it a template already, and then just make it the git contents. Create repository. So I've kind of boned myself a little bit here by not doing this method, but this is probably the preferred method. I'm definitely not going to edit this into something shorter. But then what you can do is actually, to make this even easier, is git clone your already made template, and then you don't have to set the upstream or anything like that in Git. You just clone what you want here. Now I'm going to copy all of what I have, except for the .git file. Skip it. Okay, and then I can delete this. Then, now that I have everything in here, dude, it's the recording ANSYS, you know. Can't spell anything when you're recording. Okay, and now it's all uploaded, except for the G code, which I'm going to add in after I'm uploading, after I'm already editing the video. I'll probably do it. And again, if another person wants to just rip this off without downloading it, there you go. It's right there. It's actually much easier than trying to like open up somebody's like, oh, I don't have FreeCAD. Everyone should have FreeCAD. It's free and open source. It's great. But if you just don't, but you want to whip it up really quick, it'll probably take you less time to just open up the file and see what the designer did on something simple like this. So hopefully this is something that we can all as a community do. Again, because I genuinely think this will be more robust to time and just better and save a lot of people hassle. Thank you for watching if you've stuck through, and have a nice day.